Hello everyone. In this video, we will discuss about the basics of labVIEW programming. labVIEW is the acronym for the Laboratory Virtual Instrumentation Engineering Workbench. So it is a graphical based programming language which allows for instrument control, data acquisition and pre and post processing of acquired data. It relies on the graphical symbols rather than the textual language to describe the programming. So labVIEW virtual instrumentation has three main parts: the front panel, block diagram and connectors. So the front panel interacts with the user, block diagram contains the code and the connectors is a method of connecting to other VIs. So this is how the front panel and the block diagram will look like. So the front panel is primarily a combination of controls and indicators. Control is nothing but input from the user and the indicators are output to the user. So when you place a control or indicator on the front panel, labVIEW will automatically create a corresponding control or indicator terminal on the block diagram. labVIEW has three different palettes: function palette, control palette and the tools palette. By right-clicking on the front panel, you can invoke the control palette and the tool palette. There are many sub-palettes available under control palette. By right-clicking on the block diagram, you can invoke function palette. So the functions are grouped into many categories.
Now we can see what are the various things we can do with the labVIEW software. So in a block diagram, if you see, you have a structures. In a structures you have various loops like for loop, while loop and case structures, everything. Flat sequence is nothing, the operation will be in a sequence manner. So you can right click here and put a add frame after. So what sequence we are giving here, what operation we are giving here, it will be executing in a sequence manner. After this block is completing only, the next this block will be executing. That is the use of a flat sequence. Like that you have a timed sequence. The timed sequence is same as a flat sequence, but it will be with the timer. So like that in structures you have various things. Formula node is for executing some formulas. So if you are giving a formula here and you are adding a input here, add input, how many inputs you have, you can add it here, and this is the add output. It will be executing the formula and it will be giving a output. If it is a more complicated expressions too, it will be giving answers very easily. Then you have a array. Using array we can do many functions. What are the function? Maximum and minimum, you can find it out, and array to matrix and matrix to array, like this. So sorting it, everything can be done in with the labVIEW. And cluster, we have cluster is the thing which we can bundle different variables together. If you see, you can use a numeric control, you can use a boolean control, you can use a string control together in a cluster. So I am taking a cluster control, that is a control cluster I am taking here. It is just think it as a container. You can store the various types in this container. So I can add a numeric control in this, I can add a boolean control with the numeric, and I can also add a string control using this. So different varied data types you can use in a same input cluster. So you have to use these things for a operation now. For that we can be using a cluster. You have a unbundle by name. So you can unbundle what are the things which are in a cluster, and you can use these things to the various operation. And in the output side you can use a bundle, and you can use a output cluster for viewing the output in a same cluster form. Okay, like that. the numeric you know, all numeric operations, boolean operations, string operations you can know, and comparisons, every comparison operation you can use, timing, like that we have various operations. And the waveform you can convert analog to digital, digital to analog, and setting attributes to a waveform, everything will be possible using a LabVIEW. So these are the basic things which are available in a LabVIEW software. These how you have to work. Thank you. Now we are going to study about how to work in a LabVIEW platform. So if you open a LabVIEW, you will be having a file, operate, tools, help, and the blank projects. So I am going and creating a new VI to work. If you need both the block diagram and front panel simultaneously, you can press Ctrl T. So you will be getting like this. Okay. So front panel is the panel which will contain only the controls and indicators in it, and the block diagram will have all the operations which it performs inner side. Okay. So it is a graphical programming language. It is easy to learn. It is only pick and paste operation. So now for a basic study we can go for a numeric operation. So I am going to multiply a 2 number using a LabVIEW. So you can take a multiplication operation from a numeric and pick and paste it. So you can take the control and indicator either from the front panel, you right click, go to numeric, there will be numeric controls indicators there. You can either take here or you can go to the block diagram. In the part where you need the control, you can right click that and you can create control. So the automatically when here the control is available, in the front panel it will be there. You can change the name by right clicking on that and typing what you need. So this is X and this is Y. If you change in one panel, it will automatically change in both the channels. So like that we need a indicator now for output. So you can go here, right click, create indicator. Your indicator will be there. So this is a run, this is run continuously, and this is stopping the execution. So this is run continuously. I can give my input here. So I am giving 5 and I am giving 5, X also 5, Y also 5. So I will be getting the output. You can change the control here. 6 into 5, 30. If you are giving run continuously, you can change it and do it. If you are giving run it only once, you can change the value and you can view the output. Then we can do this is a multiplication operator. Like that you can do addition, subtraction, everything using this, increment, decrement, everything using this. So like that you can do a boolean operations also. Boolean operation you have all other gates. So you can use AND gate. You can, if you go to a front panel, you will be having a boolean controls and indicators. You couldn't use the numeric control indicators for boolean functions, right? So you have a separate boolean function, push buttons and LEDs for a input and output. You can either go to front panel and select it, or you can directly go to the block diagram, right click, create controls and create indicators. Okay. If you need to clearly view, select all that, press Ctrl U, you will be having a neat look. Okay. So now I am running it. So we have given AND operation. So when both the inputs are 1, then only the output is 1. If any one of the input is 0, our output of an AND gate will be 0. So we have viewing this. And one more option here is we can create a sub VI. We can create one block diagram and we can create a sub VI for this. We can use that sub VI. So if example, if you are going to do a half adder, we can do an half adder and make a sub VI of an half adder. Using that sub VI, we can use the full adder circuit. So now we can do the half adder for your reference. So this only XR we have to add half adder circuit, right? So I am going to boolean taking an XR. So I am connecting this input. One more indicator we have to give it. Okay, and this is our sum. And this is our carry. So now we can run the program and view our output. So this is our input. So I am giving 1 0, sum is 1. When I am giving 1 and 1, my carry is 1 and sum is 0. So this is a half adder circuit now. So we can use this half adder to various circuits by you select the half adder circuit, go to an edit, create sub-VI. So now instead of having 2 gates, this if you need a half adder circuit anywhere, you can use just this sub-VI. You can control, click and paste. You can use this half adder for any other circuits. Now using a 2 half adder, using this sub-VI, we can create a full adder circuit. So one more control we need it for it. So boolean control, naming it as Z2. Two more indicators for a full adder. So full adder carry, full adder sum. Now the input of this will be the sum output of a half adder and this Z. The sum output will be now this, and you need one more OR gate for a carry to perform. So output of the second half adder sub-VI carry and the first half adder, it will go to an OR gate, and the output of that will go to a carry of a full adder. So now you can give an input. So 1 1 1 is 1 1 and 1 0 1 is 1 0. Carry is 1 and sum is 0. Like that we can perform using a sub-VI. So this is a basic study of a labVIEW experiment.